How's it going, everyone? Welcome to another video on the Enterprise UI development. Euler Gonzalez here again. This is a course taught by Steve Keeney, head front-end engineer at Temporal, this durable execution platform that the TLDR of that, and take this with a grain of salt, because this is something that I interpret from their website, is we need the challenge that now when you are deploying your application in any computers, okay, you need to find a way is to manage the health and monitoring and provide some observability tools, right? And when something gets wrong, you can easily now set up your project or set up your applications out of distance. So you can use some Kubernetes that come with their own challenge. Again, I'm not qualified to talk about that because my main role has been on the as a UI specialist, right? So I also work with the underlying technology that allows to power applications to run on any host. So that's something great. For example, Docker. So I'm quite familiar with Docker. I have experience with Docker. But the thing here is that when you're starting to scale or need to deploy more and more services, you need to find a way to manage all of those services, aka Dockers, aka containers. So tools like Docker Composers and Kubernetes come up here to say, hey, you know what? It'll be useful and helpful to create now a tool that allows us to have this kind of observability of all of these containers, and that we can now make it easy when something goes wrong, right? So for example, some Docker actually went down for some reasons, we can now actually reset that and spin it up in a new environment or spin up that service again, right? Among other features. So and also it comes with some other challenge that is like how you're going to deploy that instance or all of those instances, how you can make easy to manage all of those environments, okay? And when something runs, you need to actually make that environment aware that something runs to spin up all of those services. Again, this goes beyond the scope of today's video, but the thing here is that it is important to at least understand briefly what are the problems that they are solving. So with that, you can now have a more perspective of what they're doing, and well, here how you can provide your solution, especially when it comes to maintain this large code bases over a long period of time with a wide range of contributors with large teams or in large teams. So this is part of this course. That is the end of the goal of this course. We also look at some things that we need to actually understand. So for example, to get a big picture of what are the problems that we're trying to solve, which is one. And second is how you can now, all right, or well, the end. So the goal of today's video is to understand now more about the building process, right? So we're gonna take notes out of that, and from there, starting to build and create our own build process. So just to make a quick recap of what we have learned so far, which is understand that this course will provide us is a way of how to build as an infrastructure, which is the basic installation needed to maintain or to keep the operations up and running, and in this case to maintain these large code bases for its economy, for its judicious use of resource. So there are a couple of things that we need to flesh out here, which is, for example, what maintainability means. So I'm not going to dive too much into the weeds here as I did in previous videos. I'm going to jump straight forward to what maintainability means in the context of the software, because it's very, contextual. The maintenance you need to provide to HVAC or your fridge, your bike, your hair, your physical being, spiritual, and mental. They are different. Each one of those it requires you to do different things in order to do that. The same is for the context of software. So the idea here is that understand that what are the things that we need to do here, and that is for software, we need to make sure that we can add code to this, and not only that, we can change, update dependency, or refactor code without the feeling of breaking something, or at least reducing that as much as possible. So we have confidence of what we're shipping won't break the entire application. So with that mindset, the components of a well-architectured UI, okay, or the component of the component of a well-architectured UI application is that you need to have tests, a system test, as well as a build process, as well as on a static analysis, and also you need to define is the separation of concern between the application logic and the business logic. You need to also define is the infrastructure, the deployment infrastructure, as well as how we are going to now add new features or bug fix, right? The design process. So the ingredients for maintainability, okay, or the ingredients to build a sustainable architecture, this is something that is not fixed. It can be enhanced, but right now, okay, these ingredients to make sustainable or these ingredients to make a sustainable architecture. Okay, so what makes a sustainable architecture? What makes that this particular constructions actually is sustainable, can persist over a long period of time as much as possible, is we need to define as a system, okay, that aims to the goal of sustainability and maintainability, which is something that we described earlier. Hey, can we add code and change, mute, and refactor and update its dependency without breaking something? So we have now the testing systems, the build system, the static analysis as the base layout, and then some process to do that. So for example, code review as a way to guarantee that all of these underlying systems actually provide us a sustainable architecture. So the code review, which is something that nobody, quite honestly, a lot of the time people don't like to do this code review. And I get it, because you are reading someone else's code, you need to actually so you're reading someone else's code once, you are also need to understand how the data go through that entire workflow, which is something that is that causes cognitive load. Is also is cognitive heavy. Understand what you do, how you do, that kind of thing. And last but not least is what is the design blueprints, the design documents here, right? And then, okay, on top of that, once you're able to actually define that, we need to actually define some sort of patterns. So what are the things that we need to do, that when we set up our infrastructures, we recurrently do. The architecture, that's one of them. When we need to, so is how we're gonna organize our projects, okay? The folder structure, as well as how we're going to now is manage the state in our applications. Again, I'm talking about is on the UI development, all right? And sorry. The other is how do you put it? Yeah, exactly. The state management, all right, as well as what is the abstraction that we are using for that. So this is the pyramid of Maslow, or the pyramid of needs, when you need to when you need to define, when you need to now lay out the architecture, or a sustainable architecture when you want to build UI applications, right? So understand now this. So by looking at the broad perspective here, now we're gonna talk about the details here, which is something that it becomes quite straightforward. So for example, here we say, hey, because this particular course is going to focus on the practicality of this, not on the philosophy. So what are the things that really happens? All right. So we got some tools here that we're going to focus on, which is something that I really love about this. So for example, React, which is a service that I'm providing. So React, TypeScript, Vite, is playwright, as well as testing library. So because first we're looking at the system, the testing system, is that I'm not going to dive in too much in this, just to briefly mention that. So we have a spectrum of testing. We have the E2E, which is testing what real users actually are going to interact with our application. Usually they are being very hostile to our applications. It's quite expensive because we don't own a lot of the infrastructure in there, especially for companies. The unit testing, which is check if a particular function actually do what it's supposed to do. Integration testing, stand into the middle, is a way to actually how you can combine and test all of these different units, all right? And the component, architecture, right? So the component testing, I mean, it's like, hey, that this component actually do what it's supposed to do, and especially on React. So some definitions here is like, especially when you're writing your test, is to say, hey, you know what? You need to know about what's expectation or assertion, what is a test, what is a test suite, and then get a more practical approach when you're writing your test. So you have Vite, and here you can use the it or test as a way to write your user story, or as a way to write your test for user stories, and then the expectations, right? So the way of how you can now, or the tool we're gonna use as a way to lay out the infrastructure to set up our own, to set up a code that is maintainable over a long period of time, okay? One of the tools is using vtest, right? Vtest is now aims to be the testing environment from the front end, as a way to integrate now the development and the testing environment. So Vite is a very interesting and powerful tool, and thanks for that to exist. And then with v-tests, we look at how convenient it is to actually create this test. It is much more faster than other test runners, for example, Grunt or Bower. Okay, if you use, for example, it is faster because it is reading in Go, and now it's using ESBuild, which is reading in Go instead of JavaScript, which makes them also ESM compatible, make it easy to migrate from Jest to v-tests, and also provide you a better error report, and you can test in handling. It can handle this browser like environment. So for example, GS done or happy done. In our case, we're gonna use this happy done because it's a lightweight implementation of the DOM, and it's much faster of GS DOM, which is something that we want to do, especially when we have thousands of tests to check that each particular user story actually works as expected. And the other is a flexible configuration. So we're starting to understand now is the setup when we're writing our tests. And it's important, especially because we're gonna write unit tests as a way that this particular function do what it's supposed to do. Most of the time we need to check equality here. So that's why we look at referential equality and value equality, the difference between them, how to be this function from the expectations. Actually now check if they have the same referencing memory, and the to equal, it check if two objects has or two variables actually have the same value, and it also do this deep equality, which unlike shallow equality, which is do that one per level. If you have an object, it do that one level. So it's gonna check if the list of parameters and their values are the same per level. So to equal actually goes deep into that, which is a great thing if you really care about it. I also look at the greatest hits, which is the other thing that you might want to use. So for example, to be instance of, which what you gotta do is to check if that particular object function constructor, okay, under the proto points to a function constructor. In other words, so to be instance, say, hey, is this new class or object that you create, because objects, it is anatomy, it is made of internal properties, okay, as well as the list of property and their values. That's the anatomy, okay. It also have a particular property called proto, which what it does is to use is the prototype change. What does it mean by that? This prototype change, again, I'm gonna briefly describe that. So the prototype change is just a way of how can we have access to other property and methods in a way that we can be memory efficient. Okay, so instead of us having to create per data also another object for our functions, okay, with object.assign or with the new keyword. So now the proto, what it does is to look up to the prototype chain, is hold a reference, so it can have access to those properties. So that's exactly what is this to be instance of. It's going to check now at the proto, hey, if this proto have a link, a reference to the function constructor of that instance, great. If it's not, I'm sorry. To be undefined, to contain, hey, is this elements now is on this collection of, or is in this array collection? If it is, all right, it's gonna check their value. To throw, especially you wanna test some functions, to throw error, to match, to verify, is this actually substring matched to whatever is on this bigger string. To match object is doing the same here. It's like, hey, I want you to now match this object I want to match this object to this another object, and for that, when you don't want to check their values, you just use spec any as a way to, I don't care which value this object can have, or I don't care about the values that this particular property has. I just care about the type, that this must be a number or another type that I define. Some of the bonus that I think is quite interesting to talk about is the spec any, as I mentioned, spec array containing, spec object containing is to say, hey, the value of this must be an object that at least must contain is this property. I would also like to add this exercise here. For example, here, let me actually do this. Okay. This is for bonus. What? Okay. This is for bonus example, right? No. What? Okay. You think you're funny? Is this one, right? For example, is this. It's like, hey, I just only care about that object contains a URL property and must be of this, right? So the TLDR of this is that when you're writing your test, it is important to write with this particular practice. You define the setup, you define the test logic, and then the expectation. And it must return is only one, okay? So we also look at some of the way when you need to actually test some async metric, when you need to make all of these async tests, all right? So you have now techniques like await and async and await. The other is spec resolve or spec reject, especially useful when you want to throw an error. And some techniques when it comes to write tests for bugs, okay? So you take now the bug report, you take the problematic code, you write a test you write a failing test, okay, that needs to be passed. And the other is when you need to use these timers. Most of the time you're gonna do this is when you need to, for example, add certain, when elements on the DOM appear for a certain period of time. There's another useful case here. And the other is for dates, all right? So this is when you're gonna use the timer. And the whole point of this is to accelerate that time, because you don't want tests that actually take time or wait for something. So all right, so all of that was quite interesting as a way to understand a little bit more this testing, which is, after all, is not that hard. You just need to dedicate your time and attention to actually understand all of the finicky aspect of this. And then, all right, and then now we are here to what we really care about, which is the enterprise here aspect, right? So, which is the building step.
There is going to be a little bit of a choice time here, but like if you don't want to make a choice, you can actually just, like, I would say, fork the repo that we're using, or grab any repo you want that has tests, because it really doesn't matter. You know, like you can even like create React app and just put a test in. It doesn't, like this part doesn't matter. But what we're going to do is look, you know, to kind of, as our segue was, we talked a little bit about unit testing. We could go into component testing. We could go into playwright testing. But as a palate cleanser, to talk about something that's not testing, we're going to look at kind of setting up our first like GitHub action, right? GitHub action is basically a CI/CD process that is built into GitHub. If you've ever used it,
Exactly.
kind of setting up our first like GitHub action.
Exactly. GitHub action. So it is a CI/CD server.
Right? GitHub action is basically a CI/CD process that
Exactly. It is a CI/CD process built in GitHub, right? So they provide you is like a server.
is built into GitHub. If you've ever used anything like Travis CI or Circle CI,
So there's some question here is like, what is a CI/CD GitHub? Okay, it's a way to understand that. CI/CD, right? The what, why, and how. Yeah. This is from GitHub. Part of the DevOps. Part of the DevOps. But again, all of this is slowly to convert. So CI/CD automates your build, testing, and deployment so you can ship code, change faster, and more reliable. So, exactly. So it is a CI. So GitHub action. It is a CI/CD process built in GitHub. So according to them, automates your build, testing, and deployment, right? So automates your build, test, and deployment for that, right? Automate your build, test, your testing, and deployment. So you can ship code, change faster and more reliable. That's the whole premise of this. So you can ship code more faster and reliable. Okay, part of the maintenance, part of these things that we talked earlier is like, can we add code? Can we change code or adding or do a refactor or adding or updating a dependency without the feel of breaking something in a reliable way? So automation is a core principle for achieving DevOps success, and CI is a critical component. CI/CD comprise of continuous integration and continuous delivery or continuous deployment. Put together, they form a CI/CD pipeline, a series of automated workflows that help DevOps teams cut down on manual tasks. So a CI/CD pipeline. Continuous delivery versus continuous deployment. Exactly. Continuous delivery, and there you got it. Interesting. Again, all of this is from that. All right. And this is continuous delivery, right? So when someone says CI/CD, CD they refer is usually the continuous delivery, not the continuous deployment. What's the difference? In a CI/CD pipeline that use continuous delivery, automation pause when the developer push to a production. A human your operations security or compliance team still need to manually sign off before final release, adding more delays, or on the other hand, continuous deployment automates the entire release process. Exactly. On the other hand, continuous deployment automates the entire process. When you want to use this, for example, in software application, okay, or the software industry, but when it comes to do that in healthcare or hardware or finance, you want to actually have someone that can take a look at that and stop that process. Automates the entire release process. So continuous deployment is the ultimate example of DevOps automation. So planning, coding, building, testing, packaging, releasing, operating, and monitoring. Exactly. What are some of the type DevOps automation tools? The DevOps automation tools for CI/CD configuration management, containerization, orchestration, package managing, and web hosting. So, again, the entire reason of looking at things is because you are now integrating as another piece of operations here. You are integrating here another piece of operation. That's not separate. They just so big company actually wants to hire people that are responsible taking care of this, okay? Or at least taking care of what testing, packaging, releasing, and operating means. So for example, Perplexity. So what are the roles of DevOps? Managing IT infrastructure for software application, automating workflows using continuous integration and continuous delivery, monitoring system performance and troubleshooting, and collaborating with developers to integrate applications component. DevOps evangelist, securing buy-in from both developing and operations teams, leading training initiatives to foster understanding of DevOps practice, removing organizational barriers to facilitate collaboration, and automation architect within the DevOps framework. Automation architect, design automation strategy for deployment and testing, selecting appropriate tools for automation within the DevOps pipeline, software developers and testers. In a DevOps settings, developers take on additional responsibility beyond coding, including performing unit tests and monitoring after deployment, engaging throughout the product lifecycle to ensure quality and functionality, quality assurance in this, releasing manager and security engineer. Again, this is something that was generated by that, right? I mean, not the roles. No, where are they? No. So what are the responsibilities of a DevOps engineer? That's more straightforward question. Automation of process, infrastructure management, collaboration and communication, security implementation, troubleshooting and support, and continuous improvement. So automation of process, scripting and tool development, infrastructure management, provision and maintenance, monitoring and performance optimizations, collaboration and communications, cross-functional teamwork, stakeholders engagement, security implementation, risk assessment and vulnerability management, troubleshooting and support, issue resolution, root cause analysis, continuous improvement. So okay, so search in sources like Amazon, Google, Meta, Reddit, Netflix. Yes, search in source like Amazon, Google, Meta, Reddit, Netflix, Airbnb. Okay. Search in source like Amazon, Google, Meta, Reddit, Netflix, Airbnb. I'm missing someone. Red Hat. Okay. About the difference in response. Exactly. About the difference in responsibilities of exactly. Searching source like Amazon, Google, Meta, Reddit, Netflix, Airbnb, Red Hat about the difference in responsibilities of UI front UI engineering and DevOps engineers. Generate a table that contains such difference as well as the source link as well as the source link of your search. Iron Hack, Tech Target, AUD Club, Spaylift, Splunk, Tech Target. So okay. Primary focus, design and develop user interface for applications. Primary focus, DevOps engineer responsibility, automate and streamline software development and deployment process. Key tasks, create visually appealing and user-friendly interface. Manage CI/CD pipelines, automate infrastructure and monitoring system. Let me actually do this. create visually appealing design, prototyping, warframe, conduct usability testing, automate and streamline the software development. Work closely with UX designer and develop to ensure designs are feasible and meets user needs. Utilize design tools such as Figma, Sketch, and Adobe XD for creating interface. Analyze user feedback for that. User interactions. Focus on creating engaging accessibility, accessible and user-friendly interface. Ensure UI components are designed with security best practice to protect user data. So, why am I looking at this, right? Because, like it or not, the near future is going to merge all of these roles here. In the near future, it's going to combine all of these roles, right? In the fronting and the DevOps, the front end, the backend, and the DevOps slowly is going to merge. That's one of the reasons why, for example, director IT engineering know about that. Director engineers know very well about them. Mm-hmm. Mm-hmm. I get it, man. I get it. Mm-hmm. Mm. Exactly. So you are managing a team. You're managing Steam. You're managing Steam and stakeholders. Anyway, no. Okay. So. Oh, okay, slow down, baby, slow down. Because remember that at the end of the day, okay, we are going to slowly but progressively is. At the end of the day, we want is to make. We want to be able to ship features, change, update dependency, and refactor codes quickly, right? That's all. So because of that, especially if you're a UI specialist, that also is something that is combining with the DevOps operations, right? So to guarantee that you are now capable to add features and change and update dependency and do a refactor in a breeze. So what happened here is that certain process and certain system that we need to learn, and they're going to combine them. So the responsibility here, so the primary focus of UI especially, which is the role that I was hired, is to say, hey, I'm going to design and develop user interface that enhance the user experience. That's my role here. Okay, that's what you get hired me. It's like, let's go to develop. Okay, let's go to design and develop user interface that enhance the user experience. The other, whereas in the DevOps is to say, hey, once you design and develop this user interface, okay, now it is time for us to find a way to automate that process. Automate the process of design and develop those features, okay? Automate and streamline the software development and deployment process. So we're going to now is automate this, and that's something that is a lot of people that go to this front-end roles, or they don't understand. Do what you gotta do. Do what you gotta do, and most of the time is that by being honest with yourself. Being honest with yourself. If you want to work here, welcome. If you're not, no problem. But being honest with yourself, and that is, you eventually needs to provide value to yourself and the companies, not only for design and develop user interface, which is the key role of the UI developers. That's what this focus is all about, on the as a UI specialist or as this enterprise UI development, but also because we're talking about enterprise, large scale, big, huge, massive, Galactus, the devourer of world. We also need to look at the DevOps operation. So this is automate and streamline the software development and deployment. So not only that you are capable to design all of this user interface, not only that you're capable to design user interface, to design and develop user interface to satisfy the user needs, but also is to make that process, make the process of developing in the design, most of the time is the development, make the software development and release a breeze, automates that process. So the thing here is that these two particularly, we can draw a Venn diagram, right? So Venn, how can draw.io, is this thing, oh my god, it still exists. Interesting. Create a new diagram. Venn diagram, do you have a Venn diagram? So yeah. Venn, oh my god, there you go. Basic, bro. Basic. Invention, revolution, and tradition. Invention and tradition, there is a conflict. And in revolution and tradition, there is chaos. And invention and revolution is military. And you got the balance. Anyway, but it's yeah, whatever. The thing here is that there are things. Let me actually do this. This is now the UI engineers. Engineers. Oh my god. Engineer. Exactly. Engineer. Exactly. Okay. UI engineers. Okay. And DevOps engineers, right? Are not the same. Oh my god, I'm doing holy hell. Anyway, okay. So the responsibility here, is that design and design and develop a user interface. Okay, user interface. So that is the main goal of all of this, right? Is to design and develop user interface. Comma. So design and develop user interface. Where now the DevOps is say, okay, that's great, but we are going to automate the software development, and software deployment. Okay, so the theme, design and develop user interface, right? So the thing that we have in common is on the development, right? Is development. This is the thing in common. This is the thing in common. So automate development, automate development Okay, automate development. So automate development. This is it, man. This is it. And I think this particular graph is important to understand, right? As a way to describe the main skills, right? Or the primary focus. The primary focus, and then we can get into the details, which is create visually appealing design, prototyping, wireframe, conduct usability tests, and that kind of thing. Collaboration tools, use, performance, analyze user feedback and usability metrics, focus on creating engaging accessibility, ensure backend process support, application reliability and security, ensure UI components are designed with security best practice in mind. Implement security measures across the deployment pipeline to safeguard application from vulnerabilities. So, okay, right? Okay, cool. Cool. Cool, 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 cool. La verdad, bien. Perplexity. Ah, es mal, bro. No tienes ni idea. No tienes ni idea. Presiva. Con razón la gente con razón aquí la gente vive depresiva y depresiva, neurótica. Hablado, marico. Hablado, marico. Hablado. Es de provincia de Villagó, marico, marica. Se no. Si fuera River. Aparece. El pan apareciera en Crónica. Qué buena remontada, marico. Anyway. So, but the thing here is this, is that the whole point of this is to guarantee that. So, DevOps here, and I'm going to take here this, because this is what we want at the end of the day, okay? Okay, because we are building is this GitHub Actions. But why UI developers and DevOps exactly UI developers and DevOps piensa lo que te la gana, marica. No. Piensa lo que te dé la gana. Hay una realidad afuera. It is your. What's UI developers and DevOps? Exactly. So UI developers and DevOps. Because I think this distinction is something important, especially to understand that at least to understand these two roles, right? And what is the end goal, or what is the primary reason? What is the primary reason for they to exist? And that is, we want to maintain is we want to have the ability to add code, change it, update its dependency, and refactor in a breeze, right? And we want to make that process happen fast. We want to automate that process fast, and so on and so forth. So based on that, please. Will you? Oh, you want Ruben? Can you copy this? Copy. Oh, it's okay. This is XML. No problem. Can I export this as SVG? Yeah. What is the name of this? Oh, there you got it. UI and DevOps. Venn diagram. Authorize this app to drive. No. I want to export this here. Oh, I get it. UI, DevOps, Venn diagram. Okay, I want to download that, right? Give it to me. That's great. Okay. And is this what? Compatible? What is not compatible? Really? Can I import? Okay, interesting. It's a no. No, you won't. Okay. Okay, give it that into PNG. I didn't want to use that, but well, anyway. The PNG, download that. Be my guest. And there you go, right? So because of this intersection of interest, where you have now the UI designers, which are now specialists of building, they are now especially of designing, designing, designing and developing is this user interface that provides security to the users and usability and accessibility in mind, and that the DevOps say, hey, this process of integrating code or the development here and I want to now do something here. I want to there you go. No, you gotta be fucking kidding me. Well, anyway. Okay. Okay, so you have UI developers or UI engineers. You have now DevOps. You can say backend, right? Backend engineer, and then you have now DevOps, right? DevOps engineer. Okay. But all of this is to automate this development process. Because backend build and maintain server-side applications, database, and API. So here, backends are this. Exactly as I build and maintain server-side applications, database, and APIs, right? Pretty much is this one. Pretty much is this one, right? So UI designer is like, hey, in our case, we want to design and develop user interface as that. So it's design, right, and develop user interface. Marico, stay away from this kind of people, man. Even if your family is like, stay away from this kind of people. That's why you need a man. That's why you need a man. That's what you need a man. Not a 50-50, 80-20, no, a man. But in any case. DevOps, here we go. Okay. And here's automate, streamline. Yeah, there is a lot of jargon here, but I want to simplify. Is to automate software development briefly and deployment, right? All right. So the whole point of this is to automate the development. So the intersection of all of this is to automate, man. It's to automate, it's to automate, automate repetitive task. It's to automate repetitive tasks. I will argue is the holy grail of all of this, right? So automate repetitive tasks. As a UI engineer, you want to do that, all right? And here, automate repetitive tasks. In this case, is it's like automate UI development. All right. So what are the things that we cannot have to do in order to do this? And this is now the backend here. So automate backend development. And so backend development. So automate repetitive task in all of this, right? So the end goal of this is automation, and there is a value. Of course, there is value here. Of course, there is value here. PNG, GPG. Yeah, PNG. Front, or you say UI, backend, and DevOps, right? So you are going to be replaced if you don't if you continuously to do the same over and over and over and over. You are replaceable, man. You don't bring any things more than that. You're just a simple machines that do that over and over and over and over. It's like, do you really think that we come here for that? Down here, download. Please provide it to me. Okay, right. Yeah, you got it. Now we got a more interesting thing here. Okay. Backend. So we can say UI, backend, and DevOps engineer. And DevOps engineer. Okay, all of this. Good. I think this is something quite interesting. Oh shit, I didn't put like this exactly. Okay. Or in this case is to handle database, handle data processing tasks that support user requests as in an interaction in the application, ensure data security through proper authentication methods, secure API design practice. Exactly, all of it security, and build and maintain server-side applications, database, and API. Right? Develop and design user interface. And the thing here is that design and develop user interface, build and maintain server-side applications, and then, okay, and here, okay, communicate. So what is the relationship between UI engineers? Okay, is data communication. No, say something like this. Data. Data communication. You can say that, right? Data communication. That's the intersection of this. Hey, how can you pass now this data to the UI and vice versa? Data user and data communication, right? Interaction. User and data interaction. That's what it is. So the whole point of creating this particular graph, okay, or this particular diagram, as a way to understand that at the end of the day, there's things that you want to optimize and automate, right? Because they will provide you is the most value of all of us. Right, say delete, move to trash. There you got it. The thing that you have now in common, what the F is this? Or this? Okay, so the thing that we have all of this is in common is to whatever the thing that you're gonna do, okay, which is develop user interface or build and maintain, which is something that you have to do here, okay, build and maintain server-side applications database and APIs, okay? Both of this wants to automate that process. So we want to release those features quickly, and we can now have the ability to add a feature and that kind of thing and so on and so forth. We can update the dependency. We can now do that in a way that is so we can not only add change, but change in itself and add be able to change its dependency or update dependencies and do a refactor without the fear of breaking something, or reduce that as much as possible. So the whole point of this is to automate tasks. Why this is important? Because for example, the washing machine in your house, if you have one, or if you need to go out and use that, it actually simplifies and save you time, valuable resource in your life. So you can do other things like watch memes or learn something. So yeah, you can learn. You can not only look for memes. It's like that time that you do is like not only for look at memes or listen to music, also to learn or to take care of your kids or your pets and that kind of thing. So I think this is something that is very, very, very important as a way to understand what is the end goal of this automation. And even myself actually automates a lot of process. A lot, man. A lot. So now that we have this brief idea of what are the different roles here and how we can now maintain our applications and how we're gonna build is this CI/CD pipeline, okay, and understand that development velocity, stability, and reliability, business growth. Okay, the mindset we carry is that we always want to automate ourselves into a better job. We want to make sure that the task we're doing manually today becomes mostly automated. Director of Engineer, Andrew Mulhall. Who in the F is this? In Apple. Okay. Who the F is this? Andrew Mulhall. Is this one? PNet lead developer. An Apple Cloud Platform. Oh, mathematics, of course. Mm-hmm. Is director of Andrew Mueller, director of engineer. I think is he engineer manager. Well, in any case, but I'm aligned to what he. Yeah, I'm aligned to what he described here. You know, it's like we want to make the manual tasks of today. We want to automate the manual task of today. That's what happened, and this is a mindset. And I think that this is just to play devil advocate here. If you recognize that your time is the only, if you recognize that your time is the most important asset that you have, right? Then you realize that you have to do everything to actually not only to seize that, but to things that are manual, things that are repetitive, right? you want to make that fast, right? And this is something that drives us here from the people in the US, and also we can combine that with our need of power as well. Yeah. But in any case, that's the whole premise of this. It's like, that's what we want to do. The mindset we carry is that we always want to automate ourselves into a better job, or into a different, more creative stuff. I will say into more creative stuff. And by creating is into more, into new endeavors, into the exploration, into new adventures, into new explorations of the human capabilities. But yeah, so with that, right?
Or as I joked earlier, if you've ever had the pleasure of using Jenkins, that's a joke. Nobody's ever said. Some of those might have to do with the thing you need to change. Some of it could just be like the way that the moon was. Mostly because GitHub Actions, this is gonna be a shocker to all of y'all, integrates really nicely with GitHub. It's like you can script lots of things in your application, right? So for instance, like just like the SaaS implementation of that, and some things we use it for is like we have a public repo, which is our open source project. We have a private repo, which is just like the SaaS implementation of that. And we like our SaaS app is a superset of our open source app, which basically we use Svelte package that. And we like our SaaS app is a superset of our open source app, which basically we use Svelte's package thing, and we bundle the open source app as a package that then the cloud app consumes, which is the ability to like do user management and stuff. The nice part is when we bump the npm version in a PR, that will automatically trigger something that automatically like bumps the npm version of that in our cloud process. So the act of like cutting an open source release automatically updates to the cloud rather than prior. Cool, you merge into main. All right, neat. Now you do like npm publish. Okay, cool. Now it's on npm. Now go into the other one. And
it's trying to automate that particular process of publishing is npm
and update the dependency. Open up a PR on that. Cool. Get a code review. Merge it in. Ain't nobody got time for that, right? And so we can kind of just have workflows can signal other workflows, and all those things, and you can kind of build these like automated systems. Other things, one of the things I plan on using for in the next sprint or two, which is we merged our web server repo into our UI repo, right? Because we bundle it in that server, we release it. It's weird open source stuff, but like we merge them together. Now that said, I don't write Go by choice, and like what's nice is now I can look at like the file path that those files touch and like automatically slap the right label on it so that like somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like GitHub-y things above and beyond somebody, and like open source. And kind of build these like automated systems. Other things, one of the things I plan on using for in the next sprint or two, which is we merged our web server repo into our UI repo, right? Because we bundle it in that server, we release it. It's weird open source stuff, but like we merge them together. Now that said, I don't write Go by choice, and like what's nice is now I can look at like the file path that those files touch and like automatically slap the right label on it so that like somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like GitHub-y things above and beyond your tests. That's the most obvious things. So that's what we're gonna do first, and we'll do stuff like generating coverage reports, and eventually like and ones can see the pull, slap the right label on it so that like somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like GitHub-y things above and beyond your tests. That's the most obvious things. That's what we're gonna do first, and we'll do stuff like generating coverage reports, and eventually like saving playwright videos and all that kind of crazy stuff. But like tests is a really great first thing to do, but you can listen to issue creation, pull requests, anything like that happens in GitHub, we'll look at the list in a second. You can script and automate a whole bunch of that stuff. And this is kind of what I was talking about before. We have a hour-long release meeting that every time I seek to shave 5 minutes off of it every month, right? Until we can get it down to like our normal 15-minute stand-up where we have to do. But you can listen to issue creation, pull requests, anything like that happens in GitHub. We'll look at the list in a second. You can script and automate a whole bunch of that stuff. And this is kind of what I was talking about before. We have a hour-long release meeting that every time I seek to shave 5 minutes off of it every month, right? Until we can get it down to like our normal 15-minute stand-up where we happen to cut a release. And just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like not do a thing or convince somebody to cut them some slack than they are to turn off the build process, right? And nobody gets, we all got mad at the build process, but like not to the point where it causes team tension, right? At least we're all mad at the build process, right? And so having a lot of these things built in becomes super powerful in that sense.
Couple things that you mentioned here, especially Steve Keeney, is that when you're going to, so the most common use case when you're going to get the most value out of this is that one is from the So there's a couple of things that he mentioned, right? I think three of them. One, when you want to automate now if you have a SaaS and then you have an open source, and then you want to automate is the publishing of, and then you want to automate a particular script for that as a way to say, hey, I want you to now this npm, I want you to now any package that are in the open source, we can deploy that after we do some code review and we integrate that code to the cloud. So now it's going to be access for to everyone. So that's something powerful, okay? Especially when you want to automate is when you use some script to automate is specifically a open source package or any other package, private package that is used across the organization. So that's one of them. Okay, again, this is looking at this, the maintainability of the code. The other is that, let's say you want is to, one of them is for the SaaS and the open source, that sticks to me. The other is the other was to bundle
other things. One of the things I plan on using for in the next sprint or two, which is we merged our web server repo into our UI repo, right? Because we bundle it in that server, we release it. It's weird open source stuff. But like we merged them together. Now that said, I don't write Go by choice. And like what's nice is now I can look at like the file path that those files touch.
Is that what's nice now? Is now I can look at the file path that those files touch,
and like automatically slap the right label.
And automatically slap the right label. Exactly. So what are the files that was changed? Okay.
And like what's nice is now I can look at like the file path that those files touch.
Exactly. So now you can look at the file path that those files touch.
And like automatically
slap a right label.
The right label on it, so that like somebody from the somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like GitHub-y things above and beyond your tests. That's the most obvious things. That's what we're gonna do first, and we'll do stuff like generating coverage reports and eventually like saving playwright videos and all that kind of crazy stuff. But like tests is a really great first thing to do. Mm-hmm. But you can listen to issue creation, pull requests, anything like that happens in GitHub, we'll look at the list in a second. You can script and automate a whole bunch of that stuff. And this is kind of what I was talking about before. We have a hour-long release meeting that every time I seek to shave 5 minutes off of it every month, right? Until we can get it down to like our normal 15-minute stand-up where we happen to cut a release. And just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like not do a thing or convince somebody to cut them some slack than they are to turn off the build process, right? And nobody gets, I mean, we all got mad at the build process, but like not to the point where it causes team tension, right? At least we're all mad at the build process, right? And so having a lot of these things built in becomes super powerful in that sense. So with that, the very first thing we're going to do is we're going to go ahead. With that, you could theoretically begin to like publish your first workflow, and I'm gonna kind of just go into, if I go into the, let's just kind of talk about the component pieces in here, and then this.
Okay, all right. So what are the main use case here? Okay, so far, useful examples. Right? Useful examples of useful example of GitHub actions or useful use cases of GitHub actions. So you have now is, for example, okay, SaaS and open source. SaaS and open source code you see SaaS and open source SaaS and open source. Let's say you have let's say you have an open source. Let's say you have a public repo with the open source. Okay, let's say you have a public repo with open source with open source code, and the SaaS repo with in the SaaS in a private repo, right? Let's say you have a public repo with the open source code and private repo with SaaS in it. Okay, so when you want to update that
server, our web server thing, and we bundle the open source app. Before is like we have a public repo, which is our open source project. We have a private repo, which is just like the SaaS implementation of that, and we like our SaaS app is a superset of our open source app, which basically we use Svelte package thing.
Svelte package.
And we bundle the open source as a package that then
so we bundle up the open source package and then the cloud app consumes.
The cloud app consumes, which is the ability to like do user management and stuff. The nice part is when we bump the NPM version.
Exactly. So when they bump up, so when we bump, in UK, when we bump, when we kick when we poke. To hit something with force, when we bump. Okay, to hit something, bump, hit.
In a PR, that will automatically trigger something that automatically like bumps the npm version of that in our cloud. Version in a PR, that will automatically trigger something that automatically like bumps the npm version of that in our cloud process. So the act of like cutting an open source release automatically updates to the cloud. I'd rather trigger something that. The nice part is when we bump the npm version.
So when we bump up the npm version
in a PR, that will
in a PR, that will automatically
trigger something that automatically like bumps the npm version of that in our cloud.
That will bump automatically the npm version in the cloud
process. So the act of like cut.
So you are cutting the publishing. So the act of cutting open source release automatically. So you're cutting open source releases automatically. Exactly. So you're cutting open source release automatically.
Cutting an open source release automatically updates to the cloud rather than prior.
So you're cutting open source release automatically. Exactly. So you're cutting open source release automatically updates rather than after you need to publish that.
Cool, you merge into main. All right.
Exactly. Rather than after merge to main. Merge to main. All right.
Neat. Now you do like npm publish. Okay, cool. Now it's on npm. Now go into the other one and update the dependency. Open up a PR on that.
Exactly. Merge to main. npm publish. Open a new PR to update that depth. npm publish. So you get the idea. Okay.
Cool,
This
get a code
is
review,
one.
merge it in. Ain't nobody got time for that, right? And so we can kind of just have, workflows can signal other workflows and all those things. And you
Exactly. Workflows can signal other workflows. So workflows can signal others workflow.
You can kind of build these like automated systems. Other things, one of the things I plan on using for in the next sprint or two, which is we merged our web server repo into our UI repo, right? Because we bundle it in that server, we release it. It's weird open source stuff. But repo into our UI repo, right? Because we bundle it in that server, we release it. It's weird.
Because we bundle in that server, we release it. It is weird open source stuff.
Weird open source stuff. But like we merged them together. Now that said, I don't write Go. Sprint or two, which is we merged our web server repo into our UI repo.
Which is which is we merge our server or web server repo into our UI repo.
Repo, right? Because we bundle it in that server, we release it. It's weird.
Bundling in that server is weird.
Open source stuff.
Okay, because they don't
Repo
bundle it
into
in the
our
server.
UI repo, right? Because we bundle it in that server, we release it. It's weird open source stuff. But like we merge them together. Now that said, I don't write Go by choice. And like what's nice is now I can look at like the file path that those files touch and like automatically slap the right label on it so that like somebody from the somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like Git on it so that like, and like what's nice is now I can look at like the file path that those files touch and like automatically slap the right label on it so that like somebody from the somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the
So automatically slap
by choice. And like what's nice is now I can look at like the file path that those files touch and like automatically slap the right label on it so that like somebody from the
Okay. Automatically label. Okay. Automatically label. Interesting. To automatically labels. Okay.
somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like on it so that like and like what's nice is now I can look at like the file path that those files touch and like
how to automatically label in a repo contains the UI and the server. Yeah, how to automatically label in a repo that contains the UI and the server tags based on PR. Exactly. Tags based on PR. So for example, pull request types open and edit runs up this. You say label PR based on file change. Configuration labeling rules. GitHub labeler GML. Okay. Is this is CSX UI? This is CSS UI, HTML UI, by server Java. Okay. Labeling. Labeling front end. Labeling front and back end code. Based on PR. Labeling or label front and back end codes on PR. SaaS and Open Source publish to NPM. Label fronting and backend code on PR.
automatically slap the right label on it so that like somebody from the somebody who works on the server can like see the pull requests that are for them, and the front end ones can see the pull requests. Like there's lots of like GitHubby things above and beyond your tests. That's the most obvious things. That's what we're gonna do first, and we'll do stuff like generating coverage reports and eventually like saving playwright videos and all that kind of crazy stuff. But like tests is a really great first thing to do, and eventually like saving playwright videos.
Saving playwright videos. Okay.
Ones can see the pull requests. Like there's lots of like GitHubby things above and beyond your tests. That's the most obvious things. That's what we're gonna do first, and we'll do stuff like generating coverage.
Okay. So the things that we're gonna do here, okay, in here, okay, makes sense on GitHub. So what we're gonna do, right? What we're gonna do, right? So what we're gonna do, implement a CI/CD for testing. Exactly. What we're gonna do, implement CI/CD for testing, build, okay. Then we're going to okay, generate covering report, implement CI/CD for testing and building, generate covering report.
Reports, and eventually like saving playwright videos and all that kind of crazy.
Playwright videos, exactly. Saving playwright videos.
Crazy stuff. But like tests is a really great first thing to do, but you can listen to issue creation, pull requests, anything like that happens in GitHub. We'll look at the list in a second. You can script and automate a whole bunch of that stuff. And this is kind of what I was talking about before. We have a hour-long release meeting that every time I see like that happens in GitHub. We'll look at the list in a second. You can script and automate a whole bunch of that stuff. And this is kind of what I was talking about before. We have a hour-long release meeting that every time I seek to shave 5 minutes off of it every month.
I seek to shave it. I seek to shave it.
Right, until we can get it down to like our normal 15-minute stand-up where we happen to cut a release.
We happen to get a release.
And just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like not do a thing or convince somebody to cut them some slack.
To convince somebody to cut them some slack, and they're turned off of the build process.
Than they are to turn off the build process, right? And nobody gets, I mean, we all get mad at the build process, but like not to the point where it causes team tension. And somebody, and just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like not do a thing or
So people are more willing to not doing thing.
And just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like.
Exactly. So people are more willing to not do anything. Exactly, to not doing anything or convince that someone's slack off.
Not do a thing or convince somebody to cut them some slack.
Or convince somebody cuts them some slack. Or convince somebody cuts them some slack. Yeah, and convince somebody cuts them some slack. Or convince somebody cuts them some slack.
hour-long release meeting that every time I seek to shave 5 minutes
not
off
doing
of it every
anything,
month,
or
right? We
convince
can get it
somebody
down
to
to like
slack
a
on
normal
that.
15-minute stand-up where we happen to cut a release. And just finding those things and being able to script a lot of your process. Again, the automation, people are more willing to like not do a thing or convince somebody to cut them some slack than they are to turn off the build process.
Then they are turn turn off the build process.
Right? And nobody gets, I mean, we all got mad at the build process, but like not to the point where
Exactly. We all get mad at the build process, but not to the point to cause team tension. People are more willing to not do anything or convince somebody to cut them some slack than they are turn off the build process.
where it causes team tension, right? At least we're all mad at the build process, right? And so having a lot of these things built in becomes super powerful in that sense. So with that, the very first thing we're going to do is we're going to go ahead and
So that'll be all for this video. Take care. Bye bye.